Thinking machines, AI all around us. Hi, my name is Jeff Dorn, and I'm here for KYDA to talk about artificial intelligence. I've recently retired from a 35-year career in technology, and I want to take a few minutes to look into where AI came from, what it is, maybe what it'll become. Spoiler alert, there's some math at the core of AI, but don't let that put you off. This is an overview, not a how-to. The idea of machines performing human activities is not a new idea. We've used tools since we were living in caves. Often these tools were used for a single purpose, such as counting. And as our human numbers grew, so did the power of our tools. Once we could count everything, then we wanted to do other things with those numbers. So we'll go back to a artificial beginning because there was time before then, but let's say the first Sumerian counting board in 2500 BC, 33,500 years ago, or the abacus that came shortly after that in Asia. Widely used ability to keep track of large numbers because commerce was growing. We'll skip forward 3,000 years. The Industrial Revolution gave us steam power and then finally electrical power. And we were able to make more powerful machines. So we'll look at the Jacquard programmable loom, which was the first machine to have programming cards to control the weaving pattern. Skip forward another 50 years after that, or 100 years after that, roughly, and you get the Hollerith tabulating machine, which was an electric machine that could use punch cards and tabulate the US Census. And in 1890, they were able to shave several years off the time it took previously to count the population of the United States. Then we'll jump up to World War II and the Colossus computer, which was the first programmable electronic digital computer. It played a pivotal role in the British war effort against the Nazis. And I'll talk more about that in just a minute. Then we skip forward another 40 years or so into the 60s and 70s. And while there was a lot of change in society, technology was also changing. And as far as for our perspective, the two big items were the creation of the integrated circuit and magnetic disk, which allowed for replacing computers that were the size of an entire room with first something that was the size of a refrigerator, and then even smaller to something that could fit on your desktop. And we're looking at here at the CDC, considered one of the first 6600, which is one of the first supercomputers, and then the Apple II personal computer, which suddenly made everyone interested in having a computer. Skip forward to almost 1990 and the introduction of the World Wide Web, which, as far as from our perspective on artificial intelligence, is probably one of the more significant milestones. It allowed for computers around the world, initially just a select few, but eventually all computers, to be connected so that anyone could share information and ideas with the world. This was something completely brand new. Then we'll jump forward to Amazon's cloud service, which was introduced in 2006, which made it basically made the power of the connected servers in the world available as a pay-as-you-go service for anyone. So anyone could deploy a website, deploy a database, and use it as needed. I mean, for instance, Netflix was one of the first to use AWS cloud services as a backup. And as demand scaled for Breaking Bad or whatever, they could bring on more power just by saying, putting in their credit card and saying, give me more servers. That was an incredibly powerful event. The next one was while this wasn't the first mobile phone, it was the first smartphone, the iPhone, in 2007. And it was the first idea that, the first phone to make it not only conceivable that everyone would need to carry a powerful computing device in their pocket, but that it was desirable and everyone wanted to. So now the network is complete. So the idea of thinking machines performing human activities is an old idea. Uh, arguably, the idea that classic philosophers had that human thinking was just the mechanical manipulation of symbols was, of course, in truth, anything but simple. But it was a abstraction of what thought was. And once you had a general purpose computer, you could easily manipulate these symbols. And World War II brought a huge spurt to computer capabilities as new challenges arose. So now we had machines that could actually do some of these things. The first big test, especially came during the war, was trying to break the Nazi Enigma code. This is what the Colossus computer, which we mentioned earlier in our timeline, was. It was built by British intelligence and academia. And Alan Turing, the man pictured in the middle here, was one of the architects and lead engineers. And this Enigma, this Colossus computer, allowed the British to break the Enigma code, which was used by the German army to transmit commands and instructions every day, and the code changed every day. So it required quite a bit of horsepower to be able to break it. So Alan Turing, shortly after the war, wrote a paper, and it was about intelligent machines. And it began with the sentence, "I propose to consider the question, can machines think?" So he proposed a solution trying to avoid the philosophical and moral questions about what thinking is and what it requires, to just basically say, well, if a computer can imitate a human, then it's thinking. And his test, which came to be called the Turing test, was a person in a room is conversing with either a computer or a person in another room via, it was teletype when he created it, but think of email. And based on the answers they get back, they have to determine whether they're talking to a computer or a person. And if a computer could successfully fool somebody, then they were thinking or having the equivalent, power of thought. So this Turing test has been used subsequently to mark progress of computers. Nowadays, there's a lot of discussion about whether computers can actually do that now, and you could arguably say they can, but it's a case by case basis. So, how does a person think? Philosophers have been arguing about the human mind and how it reasons since at least Aristotle. The theory of the brain that artificial intelligence is based on today is a simple but powerful statistical model. So there's a network or web of neurons that experience stimulus and store the result in a particular path through these synapses. The mathematical model is one of probabilities and weights and can represent the data that they are given to train on, biases and all. More data is equal to a more accurate model of the data. So the model will find similarities and differences between items based on their features. While a brain uses a dense network of neurons to learn and identify objects, the AI model uses layers of software neurons with math functions to map the input to the output and build a representation of the data it was trained on. Now, these features can be anything, but preferably they're numbers. These place objects in an imaginary space. I'm showing up here as this cube, XYZ. And you can think of features as anything, any quality you're trying to measure on a person. Thinking of a basketball player, saying you're trying to compare basketball players and have AI pick one that's more, that's better based on your criteria. Could be, scoring percentage, could be vertical leap, could be minutes played. You could take all of those features and place them in this imaginary space. And now, obviously, there's more than this is a 3D space you're looking at on the left. And we humans really can't visualize anything beyond 3 dimensions. But we're going to use this just for teaching comparison right now. But the distance, you place the features in this imaginary space, and then you measure the distance between them, which is what the software, the artificial intelligence software, is doing. And then by that distance metric, it can determine what's close together and what's far away. Here, the line between Q and P would be between comparing the features of two different data points. Well, the cube and the simple geometry that represents, that's just a tool, because in reality, the actual model building is done with multivariate calculus, and it gives parabolic-like shapes, because once you go beyond 3 dimensions, there are no straight lines. Space is curved, as Einstein said, and in the real world, straight lines are rare to see, except for maybe meteor showers or something. You just have to imagine that, but the math is the same, a little more complex, but that's the general idea. And the other full disclosure is, of course, in space with lots of dimensions, the distance is not a straight line either. So we also assume that the range and values of this distance that we're using in imaginary space is what's called a normal distribution of values. This means that a random sampling will have roughly 2/3 of the values centered around that mean or average. So if you look at the rightmost part of your screen here, you'll see what's called a bell-shaped curve, and the green area in the middle is the area that most of your samples are going to come from. And this is a classic normal distribution bell-shaped curve. And it's the fact that all data is not a normal distribution is potentially problematic. But if you have the more data you gather, the more likely it will become a normal distribution. That's just one of the mathematical properties of it. And it's also why the average is so important for getting an idea. Average and this standard deviation, and what shows you here is the -1 alpha and the +1 alpha. That's the green, defines the green area. That's real simple, right? So once you have your data, now it's time to build a model. There are many models, building choices, and I'm not going to go into the details too much here, but the major choice is whether it's going to be a unsupervised or supervised learning process. In other words, how the model is going to learn. And both are useful, and they often can be combined, but initially the model building is different. Much of the natural language processing, image identification, and AI that you interact with in your daily lives is from, initially at least, supervised learning. Often many humans had input, but the gist is, do you know what you're trying to find? Do you have examples of what is and isn't your target? Or is it just a lot of data and you want to discover things about it? Which is essentially on the right here, you'll see the unsupervised is the computer draws circles around data that it finds close together in this imaginary space we talked about earlier. On the right, it's the same imaginary space, but you've given it examples of what you're interested in and what you're not interested in, or what's good and what's bad, or whatever classifications. and the computer will just draw a line based on your input. Um, you see on the left here that they show machine learning and deep learning as the examples. Um, Deep learning can be unsupervised, but generally it can also be supervised. But the idea is um, there's people involved, which is part of the supervised unsupervised thing. It shows feature extraction there. So someone is doing some rating of the data to say what you want, what you don't want. Um, so some examples of AI in our daily lives. Of course, the result of any online search you do, Google, Amazon, or any other pretty much browser you type something into. Voice recognition to identify you and your request, like I have Siri there as an example. Face recognition to unlock your phone or other security functions. NLP, natural language processing, to read and summarize the written word. It's how a lot of your news feeds are presented to you based on what the computer considers, trending. The whole idea of trending is something that's mediated by the computer. Autonomous vehicles or driverless cars, deciding where to go and when to stop. Medical diagnosis of images, symptoms, and prescriptions. Google Maps and other route selection software. And lastly, and probably most disturbingly, deep fakes in video and sound, or where a computer can not only detect a voice or face, but it can reproduce it. Here's a slight example.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this? Simply, now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet. It's a time when we need to rely on trusted news sources. It may sound basic, but how we move forward in the age of information is going to be the difference between whether we survive.
So if AI is everywhere, what's real? This is a question without a clear answer, but it's meant to make you a little more questioning about what you see and accept. When it's close enough to what you expect based on the model of us that Google, Facebook, Apple, or whoever has built, then we tend to accept it and move on. Many times that's fine, but not always. And the more important it is, money, religion, politics, or angry it makes you, the more you should stop and look for other information to support or contradict it. Maybe we're not quite walking with the in the virtual reality that this picture depicts, but there's a lot of stuff around us that it's not there without a computer to put it there. So with the availability of the cloud, AI tools, and lots of data, anyone can tackle an AI project, much like anyone can make their own movie with an iPhone and online editing software. This picture is from a site that offers to help you build your own facial recognition software. I wanted to end with this because it shows how easy and powerful the tools that are available are. Hopefully you'll be a little more aware of AI in your life. And here are 3 questions to leave you with when interacting with an AI feature: search, facial recognition, social media, advertising, news, robots, medicine, you name it. So the first question is, what data was used? And of course, by data, we're talking about the fuel that powers the artificial intelligence engine. And data can be your buying habits. Data can be um, the investments, the things you buy and don't buy. Amazon will have a model of you so that when you search, they have an idea of what things you bought in the past and what you're likely to want in the future. So model the data can be anything, but it's like gas in your car. It's what powers it's what powers artificial intelligence. So the question is, how was it gathered and what choices were made? Secondarily, with that data, what biases were built in when they asked the questions or how they collected the data or who they collected it from. There's all kinds of biases and they affects the model. Thus, it affects the answers that artificial intelligence is going to give you. Lastly, what's the product? If you're not paying for something or the service it provides, then you and your data are the product. Thanks very much for your time. Hopefully you guys can take a moment to think about how you've interacted with AI just recently, maybe today. And I look very, I hope you got something out of this, and I look forward to our next class. Take care.